Okay, so number 85 here states the Starship Enterprise returns from warp drive to ordinary space with a forward speed of 50 kilometers per second. To the crew's great surprise, a Klingon ship is 100 kilometers directly ahead, traveling in the same direction at 20 kilometers per second. Without evasive action, the Enterprise will overtake and collide with the Klingons in just slightly over 30 seconds. The Enterprise's computers react instantly to brake the ship. What magnitude acceleration does the Enterprise need to just barely avoid a collision with the ship? Assume the acceleration is constant. Okay, so what we're going to do is we're going to start off by drawing this on a graph. So it looks a little bit like this. So we have the Klingon ship going at a constant slope here. And the projected course of the Enterprise ship starts here and goes straight on and intercepts the Klingon at 3 seconds. What we want is we want a course or an acceleration that just barely misses it. So let's start with what we know. So the Klingon ship, the velocity is 20 kilometers per second, which is equal to 20,000 meters per second. The acceleration is 0 because the velocity is constant, and the position currently is 100 kilometers away or 100,000 meters away. Alright, so the USS Enterprise, the velocity is currently 50 kilometers per second, and the final velocity should be 0 because we don't want to get to that point where we hit them. And then the velocity from over here converted into meters per second is going to be 50,000 meters. Our acceleration is what we're trying to find, and the initial position is 0. So we're going to start off, we're just going to take away the velocity of the Klingon ship from the velocity of the USS Enterprise. We're going to kind of act like the Klingon ship isn't moving. So we're going to be finding the relative velocity of the USS Enterprise. And that's going to be equal to 30,000 meters per second. And so we're going to use this equation here because we don't really know the time it'll take for this deceleration to actually avoid the collision with the ship. So we're going to use this here. So we're going to use the initial velocity squared is equal to the final velocity squared plus 2 times the acceleration, which we are trying to find, in the change in position. The change in position should be 100,000 meters. So we're just going to plug all that in. So 30,000 squared equals 0 squared because the final velocity should equal 0 from up here. Plus 2 times a, which is what we're trying to find, times 100,000. And we're going to solve for a here. So just do some math here. And we are going to end up with negative 4,500 meters per second squared or negative 4.5 kilometers per second squared. Either way, however you like to look at it, that's what this looks like.